Okay. Let's talk about solving trigonometric equations. We'll start with the basic ones for this, and then I'll do another video for the more advanced to follow the Khan Academy exercises. So, to solve a trigonometric equation, we have to go back and look at our unit circle. A few aspects that we've covered about the unit circle. One, its radius is equal to 1. That's going to come back in a second. And then these parts. Sine is the vertical part of the angle, and on this drawing it is the blue line, so you can see it's vertical. Cosine represents the horizontal part of an angle, and you can see here on the drawing I have it as the horizontal axis. So sine, cosine, and then theta. Theta is just the symbol that we use to represent an angle measure or angle measures if there are multiple angles that satisfy the equation, which there are. So then we need a trigonometric equation. So we'll start out with something fairly simple. Let's say the sine of theta is equal to 1/4. Okay? There's no outside operations. We're not doing anything to the sine, no multiplication, no division, nothing. It's just sine of theta and this value 1/4. So let's break that down. Okay. First off, what it's telling me, if I interpret this equation, is that the vertical part of my angle measure is 1/4 of the unit circle's radius. Okay. So I'm going to sketch that out on the unit circle. I'm going to put the sine theta equals 1/4 on my unit circle. And what that means is that I need to find angle measures whose vertical leg would be about 1/4 of that radius. 1/4, right? Let's label that 1/4. 1/4. Yep. But I need to find the angle measure. I need to find theta. It's like finding x. 2x equals 8, and then I divide by 2, x equals 4. We need to figure out what angle measure has a vertical part of 1/4. So imagine, well, there's 1/4 of the vertical axis, and then I kind of draw dotted lines perpendicular to that. So if it's sine, I'm going to draw a horizontal line across my unit circle at this value. Sine is 1/4, horizontal line. If it's cosine, I would do a vertical line. Now, I can imagine the angles whose vertical part would be 1/4 by connecting them. There's one, but there's this other one over here in the second quadrant. Okay. So I need to imagine what would these angles be. And I can see this one's fairly shallow. It's only 1/4. Okay. But I don't know what its value actually is. And I'm going to fill in some more here so you can see that that 1/4 corresponds to this 1/4. Oops, for those angles. Okay. So we're back to those right triangles. This sine of 1/4, the vertical part of this angle is 1/4. Means that the vertical part of this triangle should be 1/4. The vertical leg of the triangle is 1/4. So I just got to figure that out. Okay. Now, I know that 1/4 is not on the unit circle. So it's not pi over 3 or pi over 6 or pi over 2 or pi over 4. So instead, I'm going to use my calculator to figure this out. Means I need to get rid of the sine. I need to get theta out of the sine, and I do that by using the inverse trig sign. So I'm going to take the inverse sine of both. So theta is equal to the inverse sine of 1/4. Okay. And then I'm going to plug that into my calculator. Okay? But it's going to give me a problem. It's only going to give me one of these angles. So I'm going to do inverse sine of 1/4 on my calculator. So let me get my calculator out. This one we're going to solve in degrees. So I'm going to make sure my calculator is in degree mode, which it is. And then we'll also solve it in radians in just a second. But I do the inverse sine of 1/4 and press enter. And you can see that it has given me 14.4775 and some more decimals degrees. We're going to go for 2 decimal places, so we'll do 14.48 degrees. So now I know that theta is equal to 14.48 degrees. Okay? That's this one. 14.48, that's in the first quadrant. Because I visualized this system, because I drew the unit circle and then interpreted, sine is telling me the vertical part of my angle is 1/4. So I know that I need to get a triangle in this unit circle whose vertical leg is 1/4. So again, I sketched out 1/4 of the vertical axis and then imagine what angles would satisfy that. Positive 1/4, negative would be down here, positive cosine, negative cosine. But 14.48 degrees, that's this first one. But I can figure out this one, okay, by, again, just using the unit circle. I know if this is 14.48, and this whole thing is 180 degrees, then this other angle here must be 180 minus that 14.48. So that's exactly what I do. I go 180 degrees minus 14.48. And I get that the value of that other angle is 165.52 degrees. So I write that. Theta is equal to 14.48 degrees or 165.52 . Those are my solutions on the unit circle. But like we saw in the last chapter, when we looked at the graphs of sine and cosine, there was this measurement called the period. And the period was how often the function repeats, or how long it takes for the function to repeat itself. And that's where we get these multiple solutions from with these. Now we have repeating values. Maybe instead of just going here and here, I went all the way around the circle and then went 14.48 degrees past that. So for sine and cosine, we have to add or subtract the period. And we can do that k times. K is a counter. You can do it as many times as you want. Okay. So that's how we get, this is called the general solution, or all solutions to the equation. Because again, it's 14.48 plus 360 one time would be another solution. 14.48 plus 362 times would be another solution. And we can continue to walk through our solution set that way. So you kind of have to imagine that if you took the unit circle and kind of tilted it a little bit, what you would see is not a disk, it's not a flat disk, but instead a kind of spiral. So we'd have 0 degrees here, and then as we went up, the spiral, or down the spiral as it were, we would see 14.48 degrees, and you just kind of have to imagine, but there's 14.48, kind of like climbing a spiral staircase. So from our starting point, we went 14.48 degrees. Around here, we would have 165.52, but eventually we would make an entire circle so that up here would be 14.48 plus 360. So 14.48 plus 360 times 1. So this angle would be 374.48 degrees. And if we did 14.48 plus 360 times 2, this angle up here would be 734.48 degrees. And I want to see. So this is how I did that. See if I can, there it is. So I did 14.48 plus the 360 times 1, and then 14.48 plus 360 times 2. Notice it follows this exact format that I have here for my answer. 14.48 degrees was my first solution. And I found another one 360 degrees away, which is the period for sine. It's also the period for cosine. Because if you go all the way around a circle, you've done 360 degrees. This is a very strange concept. I know it's very tough. But if you were walking up this spiral staircase, okay, then these would seem like very different parts of the staircase. You've gone up a level. But if you were at the very, very top of the spiral staircase and you look straight down, they would all line up because the spiral staircase would look like this circle. And you would just see a guy going here, and then he'd walk around the circle, but he'd be right there again. Whether he went up or down, they would all line up. And that's what we get with these general solutions, that everything kind of lines up. Okay. So that's the idea. Isolate, which for the basic equations, it's already isolated. And I'm going to work one out from Khan Academy in just a second. So isolate, take the inverse. I recommend drawing your unit circle so you can see visually what's going on. I will tell you, when I started with trigonometry, I could not solve these in my head. I have to, and I still do, draw my unit circle. If it's sine, I say, well, this is how much of the vertical radius it took up. If it's cosine, I say, this is how much of the horizontal radius it took up. So I sketch it out, and I draw my triangles. And then it's a lot easier to figure out what angles I'm looking for. So let's look at Khan Academy now. Let's look at one of those for this basic model we have here. So it says, the sine of x is equal to negative 0.25. So like one or more expressions that together represent all solutions to the equation. Your answer should be in radians, which I know this is hard to see, but the problem that we are given here is that the sine of x is equal to negative 0.25. Okay. So the first thing I'm going to do is, because these are already isolated, is now I'm going to sketch my unit circle. I'm going to kind of visualize, what does this equation mean? I need to interpret it. I need to find an access point to it. So I draw my unit circle. There's my unit circle. Its sine of x is equal to negative 0.25. The vertical part of my angle x is negative 0.25. So I know that from the center of my circle, the vertical part of my angle is negative, so it goes down, about 0.25. Now, if the whole radius of the unit circle is 1, then I can kind of approximate where negative 0.25 is going to be. About right there. About a fourth, because that's what 0.25 is, a fourth. And then my angle will be the triangles that I can create that have a vertical leg equal to negative 0.25 on the unit circle. So I would have this one and this one. Notice the vertical leg here would be negative 0.25. This is this angle. We always start by measuring from the positive axis, the positive horizontal axis, so 0, 90, 180, and whatever that angle is. My other solution would be that angle. So I need to find these two values for x. And again, it wants me to select one or more expressions. So again, there's two solutions. Just like the last one, 0.25 is not on the unit circle. So I'm going to use my calculator. I'm going to take the inverse sine. So here, I know that x is equal to the inverse sine of negative 0.25. Now again, it's going to go straight in my calculator. So I check my mode, make sure it is in radians, and then I do the inverse sine of negative 0.25. Let's see if I can get that into just like that. And I press enter, and it gives me negative 0.252280, etc. So I look at my answers. They go to about 2 decimal places for each of these. So I'm going to go to 2 decimal places first. So my first solution, I like the purple, so I'm going to do purple. So my first solution, x is equal to negative 0.252. So that'd be negative 0.25, so negative 0.25. Now remember, that's the angle measure. Even though it's equal to this, it's very different. We found x, the value of x is that negative 0.25. So, negative 0.25 plus or minus the period of sine. Sine and cosine are nice because their period is one circle. So as we saw on the first example, I used 360 degrees, k times. In this case, I think they use n. But in radians, there are not 360 degrees in a circle. There are 2 pi radians. So we need to do plus or minus 2 pi. And this is, n is my integer counter, so 2 pi n. So we've got one answer. So far, the one that matches what we've seen, negative 0.25 plus or minus 2 pi n, is this one, negative 0.25 plus n times 2 pi. Okay. Formatting is weird, but C is a correct answer. Okay. What we found is this. So instead of finding this positive angle all the way around, they found that negative one. That's okay. It's equivalent. But we haven't found our second solution yet. So I need to use this to figure that out. And what I can do, again, I know there's 0 radians, pi radians, 2 pi. I'm going to use this pi. Pi radians, 180 degrees. And I know that this angle and this angle must be equivalent. So if that's pi, and I'm going to go 0.25 radians farther, then I'm going to use 3.14 for pi, so 3.14 plus 0.25. It's 3.39, so I get 3.39 plus or minus 2 pi n. But that's not on here. I got this negative angle here and this other negative. Again, it's a spiral. So I can start actually doing this. Negative 0.25 plus or minus 2 pi n. Let's look at that. Let's do a couple. So negative 0.25 plus 2 pi times 1. Well, that's, let's see there. That's 6.033. 6.033, that's not on here, and it's way too big. And if I subtract pi, that's going to be way too big too. So the only one I get there is that. But let's look at the 3.39. 3.39 is bigger than any of these other answers. So the plus isn't going to, let's try subtracting. Let's do 3.39 minus 2 pi times 1. I know it's not ideal, but you get negative 2.89. So in fact, if I do 3.39 minus 2 pi 1 time, I end up with this one, negative 2.89, plus or minus 2 pi. And those are the only ones that satisfy this equation. And I found them by taking the general solution and just kind of working my way through, step by step by step by step. So those are the ones I'm going to select. We're going to select A and C. And check those. And we got it right. Now, this one. Cosine x equals 1. That's cosine of x is equal to 1. This one is giving me an interval from 270 to 810 degrees. Your answer should be in degrees, so we're in degrees now. But, again, I'm going to sketch it out. I'm going to draw a picture of this. So I need my unit circle. Cosine is the horizontal part of the angle. So the horizontal part of angle x is 1. The horizontal leg of that angle is 1, which the entire radius of the unit circle. That one we know. That's on the unit circle. That's one of those angles. 0, pi over 6, pi over 4, pi over 3, pi over 2, 5, pi over 3, all of those wonderful angles. That is 0 degrees. So I don't have to do the inverse cosine for this one. I know that if cosine equals 1, then x is equal to 0 degrees plus or minus 360 degrees in times. Again, that's my first solution, but cosine and sine repeat themselves. In fact, all trig functions repeat themselves. So it goes around the circle again. Now we're at 360. We've spun 360 degrees. We're right back at the same point. If we go around the circle again, 720. Okay. But they gave me this interval, 270 to 810 degrees. So it's not just this. I need to find solutions in the interval 270 to 810 degrees. Okay, well, we need a way to generate solutions, and that's what this does. Look at 0 degrees is a solution, and you will find more solutions by adding or subtracting 360 degrees as many times as you want, n times. Okay. So let's look at that. Well, first off, I know that 270 and 810, those are bigger than 0, so I'm not subtracting, I'm just going to add. So we're going to kind of step down this way. 0 plus 360 one time, 0 plus 360 two times, 0 plus 360 three times. So if we look at my answer choice here, 0, 90, 360, 540, 720, 1080. 0 degrees is a solution, but it is not between 270 and 810. So 0 degrees is out. 90 degrees. There's no way you're going to get 90 degrees by starting at 0 and adding or subtracting 360. 90 is out. But 0 plus 360 one time is 360 degrees. 540 is not any of these. This is 360. This one is 720. This one is 1080. So right away, I can cross out 540. It's not in my list of solutions. 0, 360, 720, 1080. Those are my solutions. The only solutions I can use are the ones generated by these lists. 720, that was there. 1080. 1080 is there, but it's not a solution. 1080 is not a solution because it does not satisfy the interval. 1080 is bigger than 810. So in this case, the only ones that I can select are C and E, 360 degrees and 720 degrees. Okay. I'm going to work this one a little bit faster. Problem here is sine x equals 0.4. So sine of x is equal to 0.4. Select one or more expressions that together represent all solutions. Your answer should be in degrees. Okay. The trig function is isolated. So I'm going to start by drawing my unit circle and kind of representing this. So that's what we're going to draw, a unit circle. Sine is the vertical part of the angle, and it is telling me that the vertical part of angle x, the vertical leg of this angle is 0.4. So I need to approximate 0.4, about half, give or take. Figure out what angles could satisfy that criteria. So we have an angle here, first quadrant, and one in the second quadrant. 0.4, not on the unit circle, not one of the ratios that we memorized. So we're going to use our calculator. We'll do the inverse sine of 0.4. And then I go to my calculator. I check the mode, make sure it's in degrees, which it's not. And I do the inverse sine of 0.4. And that gives me 23.57. So I get my first solution. X is equal to 23.57 degrees. Yeah, that's all it did. I did the inverse sine. I got that 23.57. 58 if I round. which I should. 5/8 degrees. And if I look at my diagram, I know that's the angle that is in the first quadrant that has that vertical leg of 0.4, but I haven't found the one in the second quadrant yet. So I'm going to do 180 minus 23.58. And that's just because of the diagram. I can see, if that's my first one, then my second one, this angle and this angle would have to be equal, so 180 minus that 23.58 would get me to that second angle there. So I do 180 minus 23.58, and that is 156.42. degrees. And both of those, because it's a circle and because it's in degrees, could be plus or minus 360 degrees. So I have 23.58 or 156.42 plus or minus 360 degrees as many times as I want. 1, 2, 3, 4, 5, 6, 7, 8. So now I need to look and find which one of these answers correspond to that. Well, I got my 23.58 plus or minus 360 plus 360 in times 156.42 plus 360 in times. Should be plus or minus. I don't see any restrictions on that, but that's okay. We'll forgive them for now. 293.58, that's way down here in the third or fourth quadrant. That's not going to work. If I can get rid of all those, I know 293.58 is not going to work. 66.42 is in the first quadrant. It's just too big. Complementary angle doesn't work. 21.8 is just in there to throw us off. In fact, it's only B and D that work. Okay. Let's look at the last one. Sine x equals 0. This is on the unit circle. If the vertical part of an angle is equal to 0, then the angle is flat. It's horizontal. This is 0 or 180 degrees. So it's 0 or 180 degrees, plus or minus 360 in times. But here we have an interval from 510 to 1050. So 510 to 1050. Only solutions that fit this pattern, 0 or 180 plus or minus 360, that also fall in this interval. So I start at 0. 0, it's too small. So 0 plus 360 is 360, still too small. Plus 360 again, 720. 720 works. Plus 360 again is 1080. Too big. We're going to start at 0. Plus 360 was 360. Plus 360, 720. Plus 360, 1080, and then we could keep going. We do the same thing with 180. 180 plus 360, it's 540, plus 360, 900, plus 360, 1260. And so I can see on these lists, 0 plus 360, plus 360, plus 360, 180, plus 360, plus 360, plus 360. I just need to match it up. So I got 720, 1080. In this one I get 540 and 900. Okay. Everything else is outside. If I drew that interval, 510 to 1050, 510 would look like that. 1050 would look like that. So I get the 720, the 540, the 900. Those are the answers in my interval. Those are the answers that I select there. 540, 720, 900 are my correct answers. There we go. Perfect. All right, guys. That's the basics. Practice that. I extended all the due dates until Friday, so just do the basic ones. Make sure you understand how the mechanics of that work. Watch the video, and then I will post another video this week on how to deal with the more difficult ones and the word problems. And that's it. That's all the next unit's about. We'll test on that, and then we will be in statistics.